Hi friends, welcome to GMK tutorials. It's been a long time. సో మనం ఈ వీడియోలో ఎలక్ట్రోమాగ్నెటిక్ వేవ్ ప్రొపగేషన్ ఎలా ఉంటుంది, సో దాని గురించి సమ్ బేసిక్ ఈక్వేషన్స్ నేర్చుకుందాం. అంటే ఎలక్ట్రిక్ ఫీల్డ్ కి ఈక్వేషన్ ఎలా ఉంటుంది, మ్యాగ్నెటిక్ ఫీల్డ్ ఈక్వేషన్స్ ఎలా ఉంటాయి, సో ఆ ఈక్వేషన్స్ ఎలా డిరైవ్ చేస్తాం. ఓకేనా, ఒక వేవ్ ప్రాపగేట్ అవుతుందంటే ఎలా కన్సిడర్ చేస్తాం, ఎక్స్ డైరెక్షన్, వై డైరెక్షన్, జెడ్ డైరెక్షన్. సో దీస్ ఆర్ ది సమ్, అంటే మనం వేవ్ ఈక్వేషన్ అనాలిసిస్ చేయాలి అంటే, so this video definitely very helpful for you to understand the concepts of electromagnetic theory. So let us begin to the concept. So before entering into the wave equations, so the analysis of the wave equations are the starting from the basic equations of the Maxwell's equation. So from that, Maxwell's equations in a differential form can be considered as, so these are the some differential equations. Gauss law is equal to del dot D is equal to rho V. At the same time, the absence of monopoles, del dot B is equal to 0 and del cross E is equal to minus dou V by dou T. And the third one is nothing but Ampere's law. That is nothing but it is also equal to Biot-Savart's law. Del cross H bar is equal to JC plus JD. So conduction current density and so these are the different equations related to this one. Okay, now let us move on to the, so this is a displacement current density, okay, where JD is a displacement current density. Now wave propagation in lossy different mediums. Okay, wave propagation in different media. Wave propagation lossy dielectrics lo ela untundi. So a lossy dielectric is a medium in which an electromagnetic wave loses power as it propagates through the medium. So lossy dielectrics medium means that ఏంటంటే ఎప్పుడైతే మన వేవ్ అనేది ఒక మీడియంలో ట్రాన్స్మిట్ అవుతుందో, ఆ వేవ్ యొక్క యాంప్లిట్యూడ్ అనేది లాస్ అవుతుందో, దట్ మీడియం is generally called as a lossy medium అని చెప్తాం. బట్ we were specifically discussing regarding the lossy dielectrics కాబట్టి, so an EM wave loses its power when it is propagating through the lossy dielectric medium. So in that medium, consider a linear, isotropic and homogeneous lossy dielectric medium. So the charge free, that means rho v is equal to 0. Then what is meant by linear, what is meant by homogeneous, what is meant by isotropic. So these are the different terminologies we need to study here. So linear means that the total electric field in a medium can be obtained by adding a electric field of all the waves traveling in this direction. Okay, so మనం ఒక మీడియంలో తీసుకున్నా అంటే ఒక టోటల్ ఎలక్ట్రిక్ ఫీల్డ్ ఫైండ్ అవుట్ చేయాలి అంటే, సో ఆ మీడియంలో ఉన్న అన్ని ఎలక్ట్రిక్ ఫీల్డ్స్ కానీ మనం యాడ్ చేయగలిగితే దెన్ డెఫినెట్లీ విల్ గెట్ ఏ ఫైనల్ ఎలక్ట్రిక్ ఫీల్డ్. జనరల్లీ ది మీనింగ్ ఆఫ్ లీనియర్ సిస్టమ్ మీన్స్ అంటే ఏం చెప్తాం, సో సమ్ ఆఫ్ రెస్పాన్సెస్ ఈజ్ ఈక్వల్ టు total response కి ఈక్వల్ అవ్వాలి. సో హియర్ ఆల్సో సేమ్ థింగ్. దెన్ హోమోజీనియస్ మీన్స్ అంటే ఏంటంటే ఒక మీడియంలో ది వాల్యూ ఆఫ్ కండక్టివిటీ కానీ, పర్మియేటివిటీ కానీ అండ్ పర్మియబిలిటీ వాల్యూస్ అనేవి త్రూఅవుట్ ది మీడియం కాన్స్టెంట్ గా కానీ మెయింటైన్ చేస్తే దట్ మీడియం ఈజ్ జనరల్లీ కాల్ ఎస్ హోమోజీనియస్ మీడియం అని కాల్ చేస్తాం ఇక్కడ. దెన్ ఐసోట్రోపిక్ అంటే ఏంటి అంటే పర్మిటివిటీ అండ్ పర్మియబిలిటీ వాల్యూస్ ఇన్ ఆల్ ది డైరెక్షన్. ఐసోట్రోపిక్ ఇన్ దట్ యూనిఫామ్ గా, అంటే అన్ని డైరెక్షన్స్ లో పర్మిటివిటీ వాల్యూ కానీ పర్మిబిలిటీ వాల్యూస్ కానీ సేమ్ గా మెయింటైన్ చేస్తే దట్ మీడియం ఈజ్ జనరల్లీ కాల్డ్ ఎస్ ఐసోట్రోపిక్ మీడియం అని చెప్తాం. సో ఇక్కడ ఎప్సిలాన్ అండ్ మ్యూ వాల్యూస్ అనేవి స్కేలార్ క్వాంటిటీస్ అవడం వల్ల ఏమవుతుందంటే, ఎట్ ది సేమ్ టైమ్ ది డైరెక్షన్ ఆఫ్ ది ఎలక్ట్రిక్ ఫీల్డ్ అండ్ ఫ్లక్స్ డెన్సిటీ ఇస్ ఆల్సో సేమ్ డైరెక్షన్స్, as well as the magnetic flux density and the magnetic field intensity H values also same direction because of the permittivity and permeability values are scalar quantity. It is not a vector quantity. Vector quantity అంటే దానికంటూ certain డైరెక్షన్ ఉంటుంది, బట్ మనం స్కేలార్ క్వాంటిటీస్ కాబట్టి దీనికంటూ certain డైరెక్షన్, ఓన్లీ ఆంప్లిట్యూడ్ వాల్యూ మాత్రమే ఉంటుంది. ఓకే, నౌ కమింగ్ టు ది నెక్స్ట్ వన్, వేర్ సిగ్మా is equal to conductivity, so E is equal to epsilon is equal to electric permittivity, magnetic permeability. So where D is equal to magnetic flux density is equal to epsilon times that of the electric field. So at the same time, from the Maxwell's equation, del cross H is equal, del cross E is equal to minus dou B by dou T. We know that B bar is equal to mu into H. By substituting the B value is equal to mu into H, then you will get a minus mu into del cross minus mu into dou by dou T of H cross. This is the equation after substituting the B bar value. At the same time, del cross Hs, del cross Es is equal to in phasor notation minus j omega mu into Hs, where dou by dou T value is equal to dou by dou T, okay, dou by dou T value is equal to minus j omega ki equal outundi. So from that you will get this equation. At the same time, del cross H bar is equal to sigma into E bar plus epsilon into dou E bar by dou T. So from that also dou by dou T value is also equal to j omega. So by substituting dou by dou T is equal to j omega, then you will get a second equation here. At the same time, delta D is equal to rho V, that is from Gauss law, where delta D is equal to rho V means that obviously delta D is equal to 0 because of D bar is equal to epsilon times set of the E. Okay. Next one, delta D is equal to 0, that is the Maxwell's equation related to the Maxwell's equation. So మనం ఏదైతే del cross Es is equal to minus j omega mu into Hs. So this is one equation. So దీనికి మనం కర్ల్ అప్లై చేస్తామంటే then you will get a equation like this. దీనికి వచ్చేసి మనం కర్ల్ అప్లై చేస్తే స్టాండర్డ్ ఈక్వేషన్ వచ్చేసి మనకి కర్ల్ అంటే బేసిక్ ఈక్వేషన్ del cross E is equal to S into minus del square Es కి మ్యాచ్ అవుతుంది ఈక్వేషన్. సో ఈ ఈక్వేషన్ యూస్ చేసుకొని మనం కర్ల్ ఈక్వేషన్ ని ఎక్స్పాండ్ చేస్తే ఇలా వస్తుంది del cross Es is equal to del cross minus j omega Js. So the left side part of this equation is becomes to like this. This is the equation to becomes to like this. So the delta Ts is equal to obviously 0 అవుతుంది. So because delta Ts is equal to 0. So from that minus del square Es is equal to minus j omega mu into del cross Hs, where minus get cancelled, then you will get the del cross E is equal to j omega times set of the mu into where del cross Hs is equal to obviously will get a previous equation del cross j omega మనకి ఇందాక ఈక్వేషన్ లో సెకండ్ ఈక్వేషన్ ఉంటుంది అక్కడ సెకండ్ ఈక్వేషన్ ఇక్కడ సబ్స్టిట్యూషన్ చేశారంటే del cross is equal to you will get a j omega mu into sigma plus j omega epsilon times set of the Es value అవుతుంది. Now let us consider sigma plus j omega epsilon can be treated as a gamma square and ఒక కాన్స్టెంట్ assumption తీసుకుంటే now that gamma is equal to generally called as a propagation constant గా మనం కన్సిడర్ చేసాం ఇక్కడ. So therefore gamma is equal to square root of j omega mu into sigma plus j omega epsilon. Therefore this is equal to, by substituting the equation you will get a gamma value is equal to, let us assume that gamma is equal to alpha plus j beta. Then from there del square Es is equal to, the above equation is converted to del square Es is equal to gamma square into Es కి మ్యాచ్ అవుతుంది. ఇక్కడ del square Es minus del x square, del square Es by del y square, del square Es by del z square is equal to gamma square into Es value. Why? Because the electric field is also in x component. So just we are applying the del square where del square is nothing but Laplacian operator. That value is equal to del square is equal to, just if you are applying del square is equal to Laplacian operator, dou by x square, dou square by dou x square plus dou square by dou y square, dou square by dou z square kabatti. Therefore if you are calculating for the magnetic field kabatti del square Es is equal to, if you are expanding this you will get this equation. After that, if the uniform plane wave propagates in the z direction, let us assume that where E is equal to electric field consisting of a x, y, z direction, where t is nothing but time varying, where E z comma t is nothing but that is in the z direction. Okay, so from this del square Es by del x square is equal to 0. That means in the remaining directions apart from the z direction, the electric field component as well as the electric field in x component, y component, that value is equal to 0. So therefore del square Es into del z square value is equal to minus gamma square Es is equal to 0. So this is a second order linear differential equation format. After solving the standard mathematical equation, then you will get the solutions like this: Es into C1 into e power minus gamma z, C2 into e power minus gamma z. So by applying the boundary condition, z tends to Es value is also tends to 0. That means when z value at infinite interval, obviously the electric field is also equal to 0. So from that scenario, you will get the Es is equal to E naught into e power minus gamma z, where C1 is equal to constant, from the C2 is equal to 0, therefore C1 into e power minus gamma z. So let us assume that where C1 value is equal to E naught value, then you will get a solution like this. ES is equal to E naught into e power minus gamma. This is very important question, important format. Now, for the time varying, what about the time varying electric field means that the real part of ES e power j omega t, that means if you are multiplying the ES value with the e power j omega t, then you will get the time varying electric field. Therefore, Ez of t is equal to real part of E naught into e power minus gamma z into e power minus j omega t. So by substituting these values, and gamma can be represented in the form of alpha plus j omega t, then after some simplification value, you will get a standard equation like this. This is equal to, after expanding this one, real value means that e power j theta is equal to cos theta plus j sin theta. Then you will get a finalized equation for electric field for a time varying fields is equal to E into E z of t, E of z comma t is equal to E naught into e power minus alpha t into cos of omega t minus beta z into A, where A is nothing but direction of the electric field, where alpha value is equal to attenuation constant, where wave is propagated in the z direction, where minus plus beta means that is nothing but wave is traveling in the positive z direction. So at the same time, from the maximum magnetic field equations also, del cross ES is equal to 0. By applying the del cross H values, then you will get a solutions like this. So after simplifications, these are some mathematical analysis. Just after performing this one, you will get a magnetic field equation. So simply the magnetic field equation can be obtained by dividing the electric field equation with intrinsic impedance eta value. Therefore, E naught divided by e power minus alpha z into cos of omega t minus beta z minus theta n, where theta n is nothing but the angle between the corresponding electric field and magnetic field. That intrinsic value is obviously equal to 45 degrees. Therefore, that can be represented in this equation as theta n. Okay. So any time the electric field is leads a h by an angle of a theta n. Therefore, for EM wave, electric field leads a magnetic field. So by standard equation, E naught into e power minus alpha z. So from this equation, if you are comparing this one, as the wave is propagated in the z direction, obviously E naught into e power minus alpha z, where z tends to infinity, e power minus infinity is equal to 0. That means that z is equal to infinity. Electric field is also 0. That means that alpha value is increases, the electric field E naught value decreases. That's why it is a attenuation constant. So this is all about the wave propagation of a electric and magnetic field equations. I hope this video is definitely very helpful for you for your preparation point of view. Thank you guys. Thank you.